Okay, hello everybody. My name is Maxime. Maybe first a bit about me. I work at a software company called HubSpot, where I lead a front-end team. HubSpot is a software company that offers solutions for small and medium-sized businesses. It's a CRM platform. If you're curious about front-end at HubSpot, in my day-to-day development, I'm inside VS Code with TypeScript, and we use React in the browser. Before joining HubSpot, I worked at a small startup in Belgium called PySync. I also did front-end development there. But even before that, in 2014, one day I was browsing on the internet, and suddenly I arrived at an article. It was called Thinking in React. It was on the React website. I don't remember if it was a blog post or a tutorial. But I read that article, and after reading Thinking in React, I thought, wow, this is it. I want to build UIs this way. And I guess that's also what I've been doing professionally ever since. That's as far as my day job goes. In my night job, well, after work, I work on the ReScript project. How many of you have heard of ReScript? Okay, couple. Well, for those of you who don't know ReScript is simply a programming language. It's a programming language like JavaScript in the sense that it looks like JavaScript. The syntax is like JavaScript. It also compiles to JavaScript, so that means any place where JavaScript runs, you can also use ReScript. For example, a React app in the browser, React Native, of course. If you have a backend in Node, you can also use ReScript for that. ReScript is also like TypeScript in the sense that types are a very important part of ReScript. And then ReScript is also a bit unlike JavaScript and TypeScript because it adds features that JavaScript and TypeScript do not have. Today, I'll be showing you how I built an app with ReScript. Let's start with a demo of what I built. So what you see here, it's a form. It's for a hospital. The use case is you log into a website. It's for a hospital, and then you select the doctor and you book an appointment with that doctor. So here we have the Princeton Hospital. Let's say we want to go with Dr. House. Then we pick a date. Let's say, okay, today there's no more appointments. Next week on Wednesday, I'm an early bird, so let's say 8 a.m. Then, okay, you enter your information. You add a reason. Let's say I have persistent back pain because of programming too much. So, and then you just book the appointment. The idea for this project started back in the pandemic. I noticed in my local area, whenever you wanted to book an appointment with a doctor, you needed to pick up the phone and call the doctor. I was thinking, it's 2020, how is this still possible? Why can't I do this online? I'm from 92, and when I was a kid, I was thinking 2020, well, that's the future. So here we are in the future, and we still have to pick up the phone to book an appointment with the doctor. So yeah, I kept thinking a bit about the problem. I kept thinking and thinking and thinking, and suddenly I thought, how hard can it be? These 5 words have started a lot in the past for me. I guess it was also the promise of a greenfield project. In a greenfield project, you don't have legacy code to maintain. Well, I guess at this point I didn't have any code at all. Yeah, migrations. At my work, I'm always confronted with migrations from an old system to a new system. It's also when I push code into production here, I don't risk breaking a product for thousands and thousands of customers. It's just at a small scale, which is nice. Of course, if you think greenfield project, what every engineer also thinks is, which technology am I going to use here? What am I going to use on the back end, the front end, which framework? That's what we live for sometimes. So, are we going to use Next.js? That's the standard full stack React framework nowadays. The other day I heard that the React router team also launched a new framework called Remix. Maybe it's worth checking that out. Of course, our appointment tool needs a backend, an API, so definitely GraphQL. When I open Twitter these days, it's all about rendering on the edge. I heard that Cloudflare, or I read it once, that Cloudflare has like an edge network, so definitely Cloudflare workers. But on the other hand, my app is going to start small for just my local area, hospitals, medical practices. But you know, maybe it's going to scale to the rest of Belgium, and why not the rest of Europe afterwards? So scale means high performance. Let's build it in Rust. So I kept thinking a bit about which technology should I use. And the other day I was entering a restaurant and I was getting breakfast at that restaurant. And it dawned to me that what was happening at that restaurant, they had the exact same problem that I had. So in a restaurant, a breakfast restaurant, the restaurant needs to cook and deliver breakfast, let's say with an egg and a coffee, to their customers. It needs to be at a certain time. If a customer enters the restaurant, he expects a breakfast within 20 minutes. It needs to be at an okay level. It can't be bad, but it needs to be okay. It also needs to be at the lowest possible point. If you enter a restaurant, you expect to get a lot of value for your money. Well, this is the exact same thing here. I need to build and deliver an online appointment tool. My customers are doctors and patients. I want to ship it at a certain time, and it needs to be at an acceptable quality level. It doesn't need to be perfect, because otherwise in 5 years, I'll still be building this thing. And of course, it needs to be at the lowest possible cost. What I also noticed about the production process in a breakfast, so they have 3 steps: process, assembly, tests. First of all, an order comes in. The cook makes an egg, coffee, puts it on a plate, and then a waiter gets the plate, he does a quick visual check, is the order okay, and then brings it to a customer. For me, it's the exact same thing. I need a component that represents hospitals, component that represents patients. I also need a component for the scheduling system. I throw it together, and then at the end, before shipping it, I organize a huge testing party to QA the thing. What's also important about this whole process is you want to detect and fix problems as early as possible. Imagine in your breakfast restaurant that the egg is bad or something. You give that to a customer, there are going to be 2 problems. The first is, yeah, he's not going to eat because the egg is bad. And the second problem is he might tell his friends and families, ooh, that restaurant, don't go there. Well, it's the exact same thing in software. If a customer files a complaint, it has to get its way to you. Then you have to reproduce it locally. If you manage to do that, then you have to fix the problem. Might take 1 day, might take a week, might take a month. Maybe it's not even possible to fix it in the near term. Then you get back to the customer. Meanwhile, the customer might have lost trust in your product. So here I'm sitting, thinking about technology. I'm thinking about a possible solution. Maybe I should actually start the other way around and think about my patients that have a problem. It wasn't always like that for me. If you would have given me the same problem 5 years ago, I would have started with a GraphQL server in Rust and then deployed it on Cloudflare workers, and the app would have never shipped. What changed is when I started working at HubSpot. HubSpot works a bit differently. Every engineer is paired with a designer. And as an engineer, you enter the room and you think, okay, I'm going to use this fancy framework, write clean and beautiful code, whatever that means. And you think everything is going to work out its way. A designer, on the other hand, a designer comes in the room. He sees a patient that doesn't want to call, but book an appointment online. He sees a customer with a problem. And then from that problem, he's going to work its way back to the technology. Maybe I should also do here, start with the problem and then work my way back to an actual solution. And that's where ReScript comes in at this point. Enough talking, let's give a demo of ReScript. So first of all, you need to start ReScript. It's just you do ReScript build. Boom, it started. What's interesting to note about this, it says 56 milliseconds. Yes, you're reading that right. It's only 56 milliseconds to start ReScript for this project. That's actually a major feature of ReScript. ReScript is designed to be fast from the start. It really cares about fast build times. Why? Fast build times mean a fast feedback cycle. Fast feedback cycle means fast iteration, and fast iteration means you can get your product out of the door sooner. If you compare that with TypeScript, every morning I open my laptop, I type npm start, or at least the HubSpot equivalent, and then I get a coffee because it takes so long for TypeScript to boot up. Okay, let's go to VS Code. Let's start with a new file. Let's call it doctor.rescript. So we have an appointment tool. Somehow we need to represent a doctor in our system. Start. Okay, type doctor. A doctor has an ID, of course. First name, last name. Then let's make just a doctor. Let's say Dr. House. Dr. House has first name Gregory, last name House. Wait, there's a problem here. Some record required fields are missing ID. Ah, thank you, ReScript. We forgot the ID. Let's pause here for a second. There's a couple of things that you can notice here about this code. First of all, it just looks like JavaScript and TypeScript. I mean, this could be just a TypeScript file and it would just work. That's explicit. We want ReScript to be familiar to JavaScript developers. So we just took the syntax of JavaScript and put it on ReScript. I don't know if you also noticed it, but when I was typing code, I was like writing very ugly code, maybe a bit less bad. But whenever I hit save, it formatted my code for me. ReScript comes with Prettier built-in. You don't need to do npm install Prettier. It comes out of the box for you. The third thing is, so what you see on the left is a ReScript file, and on the right, a JavaScript file. What ReScript is going to do, it's going to take a ReScript file and output always one JavaScript file per ReScript file. So you can always map them one-on-one. What we see here, so on the left we have our Dr. House, on the right we also have our Dr. House, but you can see that it's generated by ReScript code. You could also say, although this is generated code, it looks like it's written by a human. That's also a very important principle for ReScript. We want the output of the ReScript compiler to be readable. That's important for two things. The first one is when you're learning ReScript, you want to be able to compare ReScript with JavaScript. If the JavaScript is readable and next to the ReScript, then it's going to be very easy to compare and see what you're missing. And the second part is sometimes it's useful to just look at the JavaScript outputs to get a sense of the runtime. And that's something that I've been missing with TypeScript. The other day, yeah, I'm a big fan in TypeScript of, they have this concept of enum direction. So you write the cases, for example, a direction can be north, west, south, or east. I was happily using this for about a year and a half, and suddenly someone told me, oh, you have to check what kind of code TypeScript generates behind the back. First thing what I did was I filed an issue for my team, and I said, okay, let's get rid of this. I don't know what this code is, but I would personally never write it by hand. I don't want to ship this. With ReScript, on the other hand, you always have like a JavaScript file next to the ReScript file, so you can perfectly check how it's going to behave at runtime. Okay, let's continue for appointment app. We also need a function to display doctor names, for example. So let's say for Dr. House, you want something like this. Let's create a function for this, format doctor. Format doctor takes a doctor. Okay. Then it's gonna have a title, let's say doctor. And then it's gonna, okay, doctor.last name. Let's check if this is correct. So let's say Dr. House or doctor name. And we're gonna pass in Dr. House. Okay, let's again check the JavaScript output to see what this actually does. As you can see, on the left or ReScript side, we have a ReScript function, format doctor. On the right, we also have in the JavaScript output, we also have a format doctor function. Here we have our Dr. House name. On the right, we also have a Dr. House name. But this is interesting. Here on the left in ReScript, we have a function application. And here on the right, somehow it magically displays Dr. House. How is that even possible? Well, the answer is very simple. ReScript has a lot of knowledge about your program upfront at compile time. Through that knowledge, it can analyze your program and apply advanced optimizations that are simply not possible in JavaScript or TypeScript. One example of this here is that Dr. House, just boom, the compiler knows that this will always be Dr. House. It's a nice feature that doesn't exist in TypeScript. Let's return to our code. What's also interesting about this, I told you that types are an important part in ReScript. If you look at this code, I didn't write any type down outside of like the shape of a doctor, but here I didn't use any type. Compare that to TypeScript. If I write TypeScript at work, I'm always going to do like this. Doctor is of type doctor, and it returns a string. And why do I do that in TypeScript, and why don't I do that in ReScript? Well, the reason is very simple. TypeScript tries to guess the types. Sometimes it just can't, and then it says, okay, this is any, and returns any, which is kind of like, that's not so nice. ReScript, on the other hand, the type system is more strict, so it's perfectly able to say, okay, here we have a function, takes a doctor, it's always going to be a doctor. ReScript infers the types for you, so you don't have to write them, which is also nice. In TypeScript, I'm always doctor. But that actually, that's not necessary in ReScript. Let's maybe also ask ourselves the question, do we really need types to ship this app? Well, if you remember, let's maybe return. If you remember this slide, we want to detect and fix any problem as early as possible before we ship them to the customer. So if we return to TypeScript, to ReScript, imagine that, okay, you write a function for my doctor. Imagine that was just JavaScript. Okay, then you think it's going to be a doctor, but actually the truth is you can't know and you don't know. For all we know is someone passes here undefined, then this function tries to do undefined, last name, and boom, your program explodes temporarily. So let's go back. This was doctor. By using a type system, well, the type system guarantees that every time you call this function, whatever you receive, it's going to be a doctor. It's not going to be a schedule. It's not going to be a patient. It's not going to be a hospital. It's always going to be doctor. So you always know that this function is going to succeed. It's all about detecting errors up front. Types, in my opinion, are you can prevent a whole set of runtime errors just by using a type checker, which is, yeah, it's very nice. Okay, at this point you might be thinking, okay, it looks nice, but you know, this looks like a different programming language. The reason why I use JavaScript is we have an NPM ecosystem with a library for everything. Does that mean that I can't use any other JavaScript library? Well, to be honest, JavaScript is actually a VIP customer inside ReScript. A quick example of this. Let's make this a React component. The exact syntax here doesn't really matter. The point is that ReScript seamlessly integrates with React. Okay, let's maybe make this an H1. We're gonna return a string. Let's say we wanna, okay, format a doctor here. This component is gonna take a doctor. For my doctor, okay. Then let's actually render it. We have our demo app here, hello world. Okay, let's change this. Our doctor component takes a doctor prop with doctor, let's take Dr. House. Indeed, Dr. House. We just rendered our first React components in ReScript. Let's maybe inspect the elements to check if it's correct. Indeed, we see an H1 here. And then in the React DevTools, we have a doctor component. Here on the right, we have a doctor prop. It's as if we would have built this in TypeScript or just plain JavaScript. It's maybe also worth mentioning, if you look at this code, the first thing that I always do in JavaScript or TypeScript is you do like import. I want to import Dr. House from the doctor file. Well, in ReScript, that's not necessary. ReScript figures the imports out for you. It's a nice convenience feature. You don't have to write imports anymore. Okay, I'll show you one more thing about ReScript. Let's return to the appointment tool app. If you look at the basics of our appointment tool, first we get a list of doctors, so Dr. House. Then we need to pick a time slot for that doctor. Let's say Saturday, 8 a.m. And then the last step is, okay, we fill in our patient information. Okay, let's return. Let's maybe make a new file for this. Let's call it booking.rescript. Okay, so how are we gonna tackle this problem? Let's first do it in JavaScript or TypeScript, and let's forget about ReScript for a moment. So I think how I would approach this is we're gonna have something like a doctor ID. Doctor ID, if there's a doctor, it's gonna be something like 1, 2, 3, the ID of doctor, or it's gonna be undefined. Okay, the second step is we have like a date with a time slot. Okay, so time slot. Let's say this is going to something be like 8 a.m. for October. Or if the user hasn't picked the time slot yet, this is going to be undefined. And then the last step, patient information. Again, if there's no patient information, this is likely gonna be undefined. This is a perfectly reasonable solution. The one thing that I notice about this, when I get these kind of things in a pull request. When they ask me to review this code in a pull request, I'm always a bit confused, to be honest. So if you look at our UI, so first we select the doctor, and then we need to select the time slot for that doctor. But if you look at this model, actually what we can do is we can say the doctor is undefined, but we have a time slot. And then patient information is undefined. I mean, this model perfectly allows us to express that state. And in a pull request review, I'm always a bit conflicted. I don't know what the correct answer here is. Because if you look at our UI, this scenario is never going to happen. We're always going to select the doctor first, and then we're going to select the time slot. But here, if you look at just the theory of the code, then we can express this state. And I'm always like a bit conflicted. Do I need to like comment on that and say, okay, fix this or not? I once asked this to a friend because I didn't know what to do about it. And he told me, first of all, you have to take a look at the complexity of your app. And the complexity of your app is in part determined by the number of states that your app can be in. So if we take a look at this, let's count the states. We have state number 1, pick a doctor. State number 2 is select a time slot. And state number 3 is fill in the patient information. What we see here in that model is, okay, we actually have, instead of 3 states, we already have a 4th state. And I guess you can even go deeper and say, okay, doctor ID is undefined, time slot is undefined, but we have patient information, which is like not possible in our UI. So the JavaScript model is going to be like, it's going to increase the state count of your app. And as the state count of your app grows, there's a bigger chance that eventually someone is going to step on the wrong state. And if someone steps on the wrong state, then there's going to be a bug and something is going to go wrong. So let's take a look at how we would solve this in ReScript. In ReScript, there's actually a data structure that doesn't exist in neither JavaScript, neither TypeScript. And it's a data structure that allows you to say it's this or it's that. Let's have a look. You say, okay, type, let's say state of the booking. Let's return. So the first state is choose a doctor. Choose a doctor. So let's maybe make this choose doctor. Then the second one is, okay, let's pick a time slot for a doctor. So pick time slot. At this point, we already have a doctor ID because we picked one in the previous step. Okay. And then the third step is, of course, fill in patient information. Patient information, of course, we're going to have our doctor ID, we're going to have the time slots. So that's what this foreign data structure looks like. It just allows you to say, okay, it's either choose a doctor, it's either pick a time slot, or it's either fill in patient information. And then how do you use this? Let's say we want to render the state. The way you do it is you switch on the state. Let's say, okay, choose doctor. Let's just write a console log. We're gonna render it to console log. Choose a doctor step. Oh, there's a problem here. Let's check it. You forgot to handle a possible case here. For example, big time slot. That's also another advantage of this data structure. So ReScript knows about all the states up front. So here we have our 3 states. If you try and use it and you match on the actual case, then it's going to ask you, you need to handle all the cases. So let's check big time slots. Let's ignore the doctor for a minute. Fill in patient information, okay. Okay, now we handled all cases. ReScript says, okay, it's good. Let's have a look at the generated JavaScript code. Go to the booking.js file. And what you can see here is, here on the left, we have, it's kind of like a table. You just wrote out all the states, choose doctor, pick time slot, and then you said, okay, it needs to do that or that, just like a table with states and their actions. And on the right, what you see is ReScript generates for us the if else, the if branches or the switch cases, depends on the case. But what you can see here is you can just focus on the what, and then ReScript is going to figure out the low level, how it's going to work in practice. This is nice. We don't have to think about if, else if. You just write a basic table and boom, ReScript generates it for you. And that's actually how I started building this whole appointment tool. I wrote down a couple of types. I wrote down the states and then just worked my way up, to the whole app. So a couple of takeaways. First of all, always try to start with your customer. Don't be me 5 years ago, where I started with the code and somehow expected that my customer was going to change in my code. It's the other way around. You have to fit your code to your customer. Fast builds, they're important because fast builds means fast feedback cycle. Fast feedback cycle means faster iteration, and you get your product out of the door sooner. Whatever you're doing, whether it's a breakfast restaurant or software, always try to detect and fix any problem as early as possible. Types are great for that. And then if you want to make your pull request reviewer happy, count your states, try to reduce them so the complexity goes down. If you're interested about the JavaScript from the future, head over to rescriptlang.org. Thank you.